around today. First, let's look at the geologic evidence. If we look back through time, so we're saying that life started maybe 4.6 billion years ago. This first period of time, and again, you don't have to memorize any of these different names, but the Hadean era is the first era, and that's essentially comes from Hades, which tells us what the Earth was like at that point in time. So it was molten material. We were constantly getting hit by large structures from space, and so the whole thing was molten, and life really couldn't exist during that period of time. What's interesting is the point at which life could actually exist, it shows up. And so life starts here. There are going to be approximately somewhere between 3.5, 3.8 billion years ago. Some of the first life that we find on our planet are in these fossils called stromatolites, and it's essentially a bacterial or something similar to a bacterial mat that's laid over time. And so we can date that rock and figure out that first life started about 3.8 billion years ago, but it's prokaryotic. If we move forward through time, early in the history of life, photosynthesis starts. And so early in that atmosphere on our planet, there was no oxygen, but once you have photosynthesis, we start pumping O2 into the atmosphere. That actually leads to some extinctions on our planet because oxygen is very good at grabbing onto. It's highly electronegative, and so it turns a reducing kind of an atmosphere into an oxidizing atmosphere. But eventually, life starts to grab onto oxygen, so things like cellular respiration use the power of oxygen to drive that oxidative phosphorylation. So eventually, we have high amounts of oxygen in our planet, and eventually we start to see eukaryotic life show up. So this is going to be prokaryotic life. Eventually, we have eukaryotic life. Next thing that we're going to have is multicellular life starts to show up. Now we're about 1.5 billion years ago. Eventually, we show up with animals in this Cambrian explosion. We have plants, we have the dinosaurs, and then this would be us way up here, humans. And so on this whole geologic time scale, humans show up right at the end. But there is this transition from no oxygen to oxygen, from prokaryotic life to eukaryotic life, from single cell to multi-cell, to the arrival of animals, plants, and then this movement eventually onto land. And so where do we get all of this evidence? It's just geologic. In other words, we're looking at rocks and we're using absolute dating and relative dating to figure out how old those rocks are. And so the nice thing about fossils is they give us a permanent record of what life was like on